Algebra 2, we're now at 8.7c. We're going to talk about joint quadratic variation. We're up to 13 videos for Chapter 8 so far, and if you become lost or confused, just click on this description, find out which ones you've missed. In Algebra 1, it was video 12.7a, there's a link for that one too, we discussed joint variation that can be represented as the equation z equals k times y times x. And k was a non-zero constant. Now, you need to remember that if it's not in this form and it's y equals kx or y divided by k equals x, that's direct variation. And if y equals k divided by x squared, that's inverse variation. It's a quadratic, inverse quadratic variation, okay? So this is joint variation. Y varies jointly as x and z if there's some non-zero k such that y equals kxz. So it's going to affect the y jointly the x and the z are, okay? So we've got this formula a equals half bh. That's the equation for the area of a triangle with a base and height. And we say the area varies jointly as the base and the height. So this area is going to change, isn't it, depending on what that is? So if we've got this little triangle right here, this little right triangle, and this is the base and that's the height, the area is going to vary depending on the values of the base and the height jointly. So if this increases to this and this increases to this, well, then our area increased, didn't it? Together, jointly, based on these two values. So they vary, the area varies, right? So that's varying jointly, okay? We can find an equation of variation where y varies jointly as x and z. If y equals 42, x equals 2, and z equals 3, we just plug it into the equation. We substitute it in. And we solve for k. So we say instead of y, we have 42 equals k times 2 times 3. So that puts this side at 6. So 42 equals k6. We isolate the k because that's what we're solving for. So we can divide each side by this 6 next to the k. We get a 7. So our equation of joint variation is y equals 7xz, because that's going to be our constant, okay? Let's try this again. This one looks a little different because our z is now cubed. This equation says y varies jointly together as x and the cube of z. So this y is varying as x times z cubed. See that? And inversely as w. See that? Because these are the numerator and the w is the denominator, it's w is inversely. All these values are factors. There's no addition in this equation, okay? We can find an equation of variation where y varies jointly as x and z and inversely as the square of w. So we knew that when it was inversely with w, that the w was the denominator. Now it's inversely and it's the square of w. So that means we just have w squared, don't we? And the z isn't cubed anymore, it's just x and z, so that's our numerator. We can substitute these values in for y. We've got 105. K is going to stay the same. X is a 3, z is a 20, and w is going to be a 2. So we have 2 squared, don't we? Because we have the square of w. We substitute the values in. We simplify it. 3 times 20 is 60. 2 times 2 is 4. 60 divided by 4 is 15. And we can divide both sides of the equation by this 15 to make our friend the invisible 1 to isolate that k. 15 goes in 105 7 times, so k is 7. So now we have our equation of variation. We have y equals 7 times x and z and inversely as w squared. See? They vary jointly as x and z and inversely as the square of w. All right? We talked about this back in Algebra 1, and I'm going to have a link to that video in this description so you can just click on it. Our next video, 8.7d, we're going to talk about quadratic variation and proportion. Again, as I always do, I'm going to add this to the Algebra 2 playlist so you can study and review. And I have links to all those previous Chapter 8 videos that we've talked about so far, those 13 videos. And we covered direct variation and inverse variation in the last couple of videos. All right? So just remember, the ability to teach yourself this stuff, whether you're watching a video or figuring it out from your textbook, is a really good sign. It's a sign that you have self-discipline, that you're intelligent, and you have good character. I'm proud of you. All right? I'll see you next video. Bye.